Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this set of videos we are going to talk about monopolies. In this video we're going to talk about what monopolies are, why they exist, and go through a simple example. In the last set of videos we talked about perfectly competitive markets. Markets with lots of firms, all producing identical products. Monopolies are the opposite end of the spectrum, with just one firm. Monopolies are characterized by three basic assumptions. Number one, there is a single firm in the market. Number two, the firm's product has no close substitutes. And three, high barriers to entry prevent other firms from entering the market, even in the long run. The assumptions present in a monopoly leads to the firm having market power. Market power is the ability to price above marginal cost. This contrasts with perfect competition, where firms price exactly at marginal cost when maximizing profit. As with perfectly competitive markets, true monopolies may be rarer than it initially appears. For example, Microsoft is a monopoly because Windows is their intellectual property. It's illegal for anyone else to sell copies of Windows. However, Windows is not without substitutes. There are other operating systems out there that can potentially substitute for Windows. As such, we might consider monopolies to be more of a matter of degree in real life. Let's talk about a few reasons why monopolies might exist. If a firm has sole ownership of a productive resource required to produce a good, it can become a monopoly. In the modern globalized economy, this is relatively rare, but in the past was more feasible. One of the most famous examples is De Beers. De Beers once had a near monopoly on the diamond market because they owned the majority of diamond mines, largely in South Africa. Their monopoly was sufficiently strong that their advertising campaign was simply to advertise for diamonds in general rather than for their specific brand. You may remember the slogan, "A diamond is forever." In recent years, their monopoly over the diamond market has eroded, but they still remain a major player in that market. Monopolies can also be created by the government. Historically, this happened with chartered trading companies such as the Dutch East India Company and British East India Company. The governments of their respective countries granted these trading companies monopolies over trade with the Asian colonies. They were also among the first corporations in history, and the Dutch East India Company is credited with having the first corporate logo. In modern times, the government uses intellectual property to establish monopolies. This is done through copyright and patents. Over the next few videos, we will talk about the fact that monopolies are inefficient, so it might initially seem strange the government would try to create monopolies in this way. However, the reason that they're doing this is to incentivize innovation and creative activity that might not otherwise happen without patents and copyright. Patents and copyrights do eventually expire, which serves to mitigate the inefficiency in the long run. Finally, natural monopolies exist because a single firm can supply a good at a lower cost than could two or more firms. This generally happens because of high capital investment required to operate these firms, as well as extreme economies of scale. Recall that economies of scale means that it's more efficient to be larger and produce more output. With extremely high economies of scale, it could simply not be feasible to have two firms operating in the market. Natural monopolies often coincide with club goods, like toll bridges. It just wouldn't make any sense to have two competing toll bridges right next to each other, because of how expensive it is to build a bridge. Public utilities are also a good example of this. Operating an electrical grid requires a massive amount of investment in power lines. Imagine if you had a town with two competing networks of power lines going all over town. It just wouldn't make sense because of how costly that would be. The formal mathematical definition of a natural monopoly is one with a large fixed cost and a low constant marginal cost. When marginal cost is constant, average total cost is always decreasing and never crosses marginal cost. We'll come back to the concept of natural monopolies later on, and I will show you an example. Let's look at a simple example of monopoly. As with any other firm, a monopoly's objective is to maximize profit, which we define as total revenue minus total cost. As with perfect competition, we are going to look at the monopoly's decision as a quantity decision. Unlike a firm in perfectly competitive markets, though, monopolies are not price takers. They are not a small part of the market relative to the whole market. They are the whole market. So if a monopoly wants to increase its quantity, it's going to have to decrease the price according to the law of demand. In the first two columns of the table, you can see that as quantity increases, price has to come down. This is just moving along the demand curve. As quantity goes up, total revenue is going to change, and total cost is also going to change. The amount that those two things change are the marginal revenue and the marginal cost. The monopoly can increase profit by increasing quantity if marginal revenue is greater than marginal cost. On the other hand, they should decrease quantity if marginal revenue is lower than marginal cost. Let's fill in this table and see what our monopoly is going to do. We will first use the demand schedule to build out our total revenue and marginal revenue. Total revenue is price times quantity. 0 times 400 is 0. 1 times 360 is 360. 2 times 320 is 640. And so on and so forth. I'm going to go and fill this in all the way down. What we notice about these numbers is that initially they are going up, and then eventually they start dropping down. This has to do with the elasticity of the demand curve. In the top half of our schedule, the quantity is low and the price is high. This means that the demand curve is elastic at this point. Increasing quantity and dropping the price will increase revenue. In the bottom half of our schedule, we have a high quantity and a low price, corresponding with an inelastic demand curve. Increasing quantity requires such a big decrease in price that total revenue is going to go down as price goes down. Revenue is maximized somewhere in the middle where we have unit elasticity. We calculate marginal revenue as the change in the total revenue over the change in quantity. In our case, change in quantity is just 1, so we just have the change in the total revenue. Going from 0 quantity to 1 quantity, we're going from 0 revenue to 360 revenue, so that's just 360. Going from 1 to 2, we have 640 minus 360, which is 280. Going from 2 to 3, we're going from 640 to 840, a difference of 200, and so on and so forth. We can see that once the total revenue starts going down, marginal revenue drops into the negatives. Notice that at any given quantity, marginal revenue is always lower than the price. For example, at a quantity of 2, the price is 320 and the marginal revenue is 280. At a quantity of 3, we have a price of 280, a marginal revenue of 200. This is because to increase quantity, price has to come down. Every time we increase quantity, we're selling one more unit, and we're selling that at the new lower price, but all of the previous units would also have to be sold at that new lower price. And so this is going to drop marginal revenue below the price. The last column that I'm going to fill in here is the total profit. And I'm going to use the equation right here, profit equals total revenue minus total cost. At 0 output, we have a total revenue of 0, a total cost of 300, so negative 300. At 1 output, total revenue is 360, and total cost is also 360, so we have a profit of 0. At 2 output, we have a total revenue of 640 and a total cost of 400. That leaves us with 240 profit. At 3, we have 840 revenue, 420 total cost, which leaves us with 420 profit. Next, we have 960 revenue and 460 total cost, so that's going to be 500 profit. At 5 output, we have 1,000 revenue, 520 total cost, so we have 480 profit. We've now found the point where profit maxes out, and we're going to see a decrease from here. I'm going to go ahead and fill the rest of these in. From our profit column, we can see that total profit is maximized at a quantity of 4 and a price of 240. We can use our profit maximizing rules to see this as well. We compare marginal revenue with marginal cost to see if it's worth increasing output. The first unit is worth producing because marginal revenue of 360 exceeds the marginal cost of 60. For the second unit, 280 exceeds 40. For the third unit, 200 exceeds 20. For the fourth unit, 120 exceeds 40. But for the fifth unit, the marginal revenue of 40 does not exceed the marginal cost of 60. This means we're best staying at 4 units to maximize profit. Notice that revenue is maximized at 5 quantity and 200 price. This shows us that maximizing revenue and maximizing profit do not happen at the same place. In the next video, we will make things a little bit more complex by maximizing profit algebraically and graphically.